What we're going to do in this exercise is make a sheath to cover this power adapter so that the two halves don't fall apart. So obviously we could glue this, but being that this is an object that's used quite frequently, the glue will eventually fall apart. So we want a sheath that covers the two parts and holds it all together. So our measurements for this, it's slightly wider at the cable end than it is at the USB-C socket end. So it is 8 millimeters on this end, 6 millimeters on this end. It's 37 millimeters in length and is 14 millimeters across. So it's basically a box that's slightly narrower at one end than it is at the other. It's also got rounded or curved profiled sides. And we don't necessarily need to construct these specifically because they will curve based on the way that the mesh is constructed. So when we add subdivision surface modifiers, the edges will curve naturally as a consequence of the subdivision surface, and it will provide us the correct curvature. So let's switch to Blender and start modeling. So in Blender, as we're going to be printing this, 3D printing, we need to set up the scene's units to millimeters to match the printer. So we want to be in Scene Properties, Units, enable millimeters as our length, so we're changing meters to millimeters, and we want to change unit scale to 0.01. This will make the grid go very large because what we've essentially done, so if we change that back to 1, change that back to meters, view sidebar, so we can see by default the cube is 2 by 2 meters, so 2 by 2 by 2 meters. So if we change to millimeters, that changes to 2000 millimeters because it's using the meter scaling, which is unit scale 1.000. So if we change that to 0.01, we get millimeters, which changes the dimensions of our object to 20 millimeters, but the grid remains relative to meters. So to change that, so we're working with a grid that also is set to millimeters. We want to be in viewport overlays, and we need scale to be the same as unit scale. Viewport overlays, click type 0.01, and that changes the scale to match. So what that then means is that the major grid is 100 millimeters, so that's 10 by 10 blocks, and the minor grid is 10 millimeters. So the default cube being centered on the grid is 10 by 10 by 10 per quadrant, or 20 by 20 by 20 overall. So that's the project's units system set up. What we also want to do, because we need a degree of accuracy, is that we have to enable the system's numerics so that we can see selection length, or our edge length in this particular case, but we can only access that in edit mode. So we can make a quick switch to edit mode, object mode, edit mode, and that will give us our edit mode options. So if we click on that, we've got edge length. We can enable that and it will give us the length of all our edges, or the edges that are highlighted and selected. At the moment it's 20 millimeters. So if we switch out of edit mode, now that we've got that set up, back into object mode, we can do some basic editing. So I'm going to use our dimensions. So before we do that, let's just double check which way we are facing. Viewpoint, front. So that's view, viewpoint, front. That will give us So there we go. That reorientates the scene so we're facing the right way, and now we can change the dimensions. So at its tallest it's 8mm, so click type. X, that is 14, and Y is 37. So that is our object's basic shape. So if we go into edit mode and do some editing, we just need to make one end slightly smaller than the other. So if we go into edit mode, and we can see that it's still reading 20mm. So Blender hasn't reset our object, so we have to do that manually. So back into object mode. So make sure the object is selected, because what we've done is essentially by changing the shape of the object, we've changed scaling, but Blender keeps the original scale size reference or the dimensions references, which is why it reads as 20. So we have to reset it so that all the dimensions that are visible in edit mode are the correct ones. So we have to reset. To do that, make sure the object is selected, object mode, apply, and then we want rotation of scale or all transforms. Either or will work. And that resets the scale. So now everything is 1 by 1 by 1. So if we go back into edit mode now, we can see all our measurements are correct. So for our shape, we want to switch to edge select, select an edge. So we're going to make this end the smaller end. It doesn't matter which one. I'm going to use the move widget. And we're going to click drag the blue handle, hold Control and then Shift at the same time, and that will allow us to manipulate the selection snapped to smaller increments of the grid. So in this case that's millimeters is what we want. So click drag down, there's 1mm, select the bottom edge, click drag up, holding Control Shift again, and we get our 6mm. So if we just select all, so there we can see 6mm. There's our width and obviously our length. So what we have is a smaller end at the USB socket and a larger end where the cable goes. So that's our basic shape. That's literally all we need to do. So let's exit edit mode, object mode. Just to make this easier to see, let's object properties, let's enable viewport display, let's enable wireframe. We're going to save this. Let's just rename this step 1. Click type, step 1. File, save as. USB sheath 1. Save as. So that's step 1. So now that we've got our block out, what we can do is just move that to one side, duplicate, object, duplicate, escape to reset, move that to the center. So for the next step, so we'll call this step 2, so double click in the outliner, step 2. We want to be in modifiers. So modifier properties, add modifier, generate, and we want subdivision surface. That will do that to the mesh, so it'll collapse it essentially. What we can do here is go into edit mode so that we can edit the shape and get the actual shape that we need. So edit mode. So we can see a ghost of the original. We need to use the loop cut tool to add some loop cuts so that we define this shape relative to what we actually need. So loop cut, one in the middle, quarter, quarter, and then one down the center. And then to get the edges, so we need these to be flat surfaces at this end and this end. And we do that with geometry, not with marking edges as sharp as we might ordinarily do. So we don't need to use that, we do it with geometry. So click, drag all the way to the end, release, click, drag all the way to the end, release. Let's increase the levels. So those edges aren't quite sharp enough, so do it again, click, drag, click, drag. And that is the shape that we need. We don't need to add a loop cut around the waist of our object, because if we do, it's going to square off this curvature that we need. So the curvature of the adapter is actually much smoother, which is broken essentially. So let's just undo that. That's broken if we add a loop cut around the waist, so we don't need one there. So that is literally our plug casing shape. So that's going to be our template that we're going to use for the next step, which is building the sheath or the shroud that goes over this. So exit into object mode. What we can do here as well is object, mesh smoothing, object, shade smooth, select none. So that's step 2. So let's save this file, save as 2. So now that we've got that, the next step is to create the outer sheath. So there are a couple of ways of doing this, but for clarity, let's just select the original, duplicate, escape to reset, and just move that to the side. What we want to do here, because this is the outer sheath, we need to get rid of these 2 end faces. So edit mode, face select, click, shift click, delete, mesh, delete, faces. Now we can replicate the subdivisions. So we've still got the loop cut tool active. 1, 2, 3, and then 1 across the top, and of course 1 across the bottom, because we don't have the continuation of the surfaces for that to loop round automatically. We're in modifier properties, so add modifier, generate subdivision surface again. Increase the levels. And that is the aligning of our sheath. So what we can do next is we can either, let's just go back into object mode. So let's duplicate this. Object, duplicate, escape, move that to one side. So what we can do here is duplicate this, escape, and using the scale widget, we can scale along specific axes. So click, drag, hold control, snap to the increments, so we can make it wider and taller, like so, to give us our shell. We can then join the two together, but before we do, Viewport overlays, enable face orientation. So this is important because what we want are the faces pointing the right way. So blue points outwards, red points inwards. In other words, to the inside of a mesh. If we use this approach where we're duplicating meshes, we need to invert this inner shell. We need to invert those faces so they point, so the blue points inwards or indicates that the surfaces are pointing inwards, and the red is where the blue is. It'll make sense when we do this. So the way that we do this is to select the inside, edit mode, select all, mesh menu, and then here we want normals flip or recalculate inside. And that flips all the faces so they point inwards, which now means that when we join this together, form a solid object, the faces are all pointing the right way. So for that, object mode, select the outer skin, the inner skin, object, join. This will join them together into a single unified mesh. And then what we can do, let's just lower the levels for this next bit, make it clearer to see what's going on. So that is our base shape. So what we want to do now is toggle back into edit mode, and then using edge select, move manipulator widget, we need to select our edges and fill them. Vertex, new edge, face from vertices. Shortcut key is the F key, F for Freddy. That will create a face that fills and solidifies essentially our object. So F key, F key, F, F, F. So now we are creating a solid shape. So if we now re-enable our levels, we need to do a little bit more editing to the mesh because we need these ends to be flat rather than what they're doing right now. So we use the loop cut tool again, click drag on the outside, click drag on the inside. And that creates a sharp edged shroud object mode that will sit, move, that will sit over the top of our casing. So that's approach 1. Approach 2, let's just disable viewport overlays, face orientation. So an alternative approach, select our object, add modifier, generate is to use Solidify. And what we can do here is change the thickness to thicken the mesh. So right now it's 0.1 millimeter, so we can just click type 1 millimeter. But as we saw with, let's just enable face orientation again, because the faces are orientated the way that they currently are, blue pointing outwards, red pointing inwards, when we thicken the mesh, in this particular instance, it thickens inwards. So it's thickening away from the outer surfaces. So to thicken outwards, so from the outer edge that way, we use a negative value in the thickness setting. So -1. That thickens outwardly, which now means that will sit nicely over our casing. So that's two ways that we can create a solid object like this by duplicating and then joining the meshes together, filling the shapes and doing a bit of editing, or just using the Solidify Modifier. So we can play around with the settings a little bit. So let's say 1.25. And that makes it relatively easy to adjust the thickness of something on the fly rather than manually creating it. So let's disable face orientation, and that is our shroud. So we've manually created it, duplicating the inside to the outside, and we've used the Solidify Modifier. So that's step 2, that's step 3. Let's call this step 4. And then step 5 would be to export these for printing in the printer. So let's just save this. File, save as, number 3. So for that, if we've used modifiers, we need to assign or apply the modifiers first before exporting, because the order in which the modifiers are assigned can change the final result. So when exporting, the export scripts just go down the list. So if it applied the subdivision surface modifier first, it might change the appearance of the mesh negatively, which we want to avoid. So we are best off manually applying the modifiers. So we'll apply Solidify first. So let's just duplicate this so that we keep a copy of our object. Duplicate, escape, move that to one side. Let's do the same with the other one whilst we're here. Escape, move that to one side. So more options. Apply. We might need to do some editing to the mesh. Edit mode. Outside and inside. To get our sharp edges, and again we're not using the sharp modifier. But one thing we might need to be mindful of is, because there is a loop cut down this center line, there's actually a difference. So if we go into View, Viewpoint, Front. So if we look at this distance and this distance, this one is slightly thicker than this one, and we can see that our profile is slightly convex. So we need to address that before we export, and that's happened because there isn't a loop cut on this center line, because the way the subdivision modifier works, it subdivides based on the structure of the mesh. So if we've got this distance is not the same as this distance. So that means the distribution of subdivisions is different between the two areas. So there are larger subdivisions in this area than there are in this area, which results in this difference. So we have to correct that. So view, viewpoint, top, switching to wireframe, vertex select, switch to the move widget, and then we're going to click drag a selection box. So we're selecting this outer set of vertexes, and then shift click, drag a selection box for that outer section, view, viewpoint, front, and then scale widget. Click drag Z-axis or Z-axis, hold shift key down and straighten that up. We also want to widen this, so click, drag on the X in this particular case, Control Shift, that should, so we're going to solid mode, that should equalize that out. If not, let's just do a quick extra edit. So that's now the same as that, and ready for export. So again, make sure that we have as sharp an edge as we can get. Object mode, and then we can apply subdivision surface modifier. So more options, apply. So that is now ready for export. So for the one that we created manually, we don't have the Solidify modifier, so we just need to apply subdivision surface. So to export, before we do actually, let's just save this file, save as. Let's move this to one side, hold Control, snap to the grid. That's step 5. And that's step 6. Now to export, all we need to do, select our objects, make sure they are centered on the grid, File, Export, STL. So that's step 5. Let's just call that step 5 so that we know we want selection only. Apply modifiers, that is enabled by default. So this is where we were saying before that we want to apply the modifiers manually so that it doesn't inadvertently cause problems for the mesh, because the export process just goes down the list. And we want to avoid doing that, but that's assigned by default anyway. And then all we need to do, export STL. So that's 1. Let's move that back out of the way and move our manually created one. Same again. This is number 6. Let's export STL. Same again, it should keep the settings. We'll just name this 6 and then export. So now we need to bring these into our slicer for prepping for printing. So now that we've got our STL files, we can open them in our slicer. So open browse to, select, open. Now, if on importing into our slicer the object is tiny, we don't need to worry about that because we can change the scale of the object depending on the tools that are available to the slicer. So we'll select our object, and using the scale tool, we'll just make sure uniform scaling is active, and then type 1000. And that should rescale to the correct size, and in this case we can see that, let's move that out of the way so it's easier to see, we can see that down at the bottom here. So where all these tools are and their availability will depend on the slicer that's being used. But generally speaking, the difference is due to the way that Blender handles scale, size, dimensions versus our slicers. So always keep that in mind. Now that we've imported the mesh, what we can see from doing this, we've got some red areas that indicate issues for the printer. And that's because we have this laid down flat, so that missing wedge, because of the size difference at either end, that doesn't have any support for our 3D printer, so it's a problem area. And the same goes for the inside. That's not supported, so that's also going to be an issue. But for this, what we want to do is actually rotate this, because we want to get the maximum strength from our object, from our printing medium. And as this prints horizontally, that's going to create striations in our final object, which are points of weakness. And because of the nature of what this is, we're dealing with physical forces that go with the grain of the print. So these are all layers that form stress points or points of failure, fracture points that we have to consider. So in this particular instance, the way that we get around that is that we can rotate our object, rotate tools, 90 degrees. That will fix most of the issues, in fact all the issues aside from the bottom, because that's the bottom of the print. That'll fix most of the issues and give us a functional print. So we now need to slice this so that we can see what the end result will be like. Preview, and that is what's going to be printed. So all we need to do now is, if we want, we can change whether there's an infill or not. So we can see how the printer is going to print, whether this will be a solid object or not, depending on the thickness. And in this case, it looks like it's generally going to be a solid object regardless as to whether there's an infill or not. So once we've got all that set up, that's all we need in this instance, and we just saved a file as a G-code, which is compatible with the printer. So then all we need to do is transfer the file and then print it. So as a slight addendum to this exercise, because we are printing something, or we're making something in Blender that needs to be printed with some degree of accuracy, we need to be mindful that physical changes might need to be made to the model in order to compensate or accommodate the 3D printing process. because the 3D printer's nozzle might be 0.2 millimeters in size, but the bead that's extruded out of the nozzle is 0.5 millimeters, which obviously changes the dimensions of what's being printed. So we have to be aware of this in terms of the model that we make. So we have our original, we have an adjustment to try and compensate for this original being too small. This one was too big, and then the third iteration was the right size. And as we can see, relative to the original, it's slightly wider in order to accommodate the curvatures at both ends of the sleeve. Similarly, we have to pay attention to how our modifiers stack, how our modifiers of that subdivision, and in this case we're using Solidify, how that changes the structure of the mesh relative to the actual cage, the low resolution cage that is modified by our modifiers. In this case we can see that it's essentially shrinking the structure that will be exported, which then leads to the problem of it being too small, which then has to be adjusted to compensate, that being too large, and then readjusted to make it fit correctly. So again, because we're dealing with physical properties, we have to be aware that we may need to do some compensatory adjustments to our model in order to make it work. So that's designing a power adapter sleeve in Blender and 3D printing it. And here it is in place after a little bit of cleanup.